Hello and welcome to another video of Pi International Education. Our today's topic will be algebra word problems. When we are going to solve word problems, we will be coming across something that what we call unitary method, which is very much essential for the algebraic manipulations. In this example, John can clean 7 cars in 3 hours. How many cars can he clean in 8 hours? It's a very basic problem and it's very easy to solve. But how are we going to approach it? At first, we have to know what the conversions are. That he can clean 7 cars in 3 hours. Now, in the unitary method, there is a way of solving this problem. At first, you have to know what they're asking in the question. In the question, they're asking for how many cars. Whichever they're asking for, you have to keep for the end and the others in the beginning. So they have asked for how many cars. So we're going to put cars in the end and 3 hours in the beginning. I have rewritten the question. 3 hours equals 7 cars. According to unitary method, if John took 3 hours to clean 7 cars, how many cars would he clean in 1 hour? In 1 hour, he would clean less than the car he would have cleaned in 3 hours because he has got less time now. So it would be division, right? 7 by 3 cars. And now the question asks us how many hours, right? So 8 hours, John would clean 7 over 3 times 8. So that would give us 56 over 8 cars approximately in 8 hours. In order to solve the ACT problems, we have a time factor. We don't have that much time. So in order to solve this kind of problems, we don't have time to write so many things. So there has to be an easier way to come up with. Let's do that. For this kind of problems, we have to first find out what we call the conversion factor. Over here, the conversion factor was 7 cars equal to 3 hours. So 7 cars equals 3 hours. And now what we need to find out is how many cars in 8 hours, right? For 8 hours, let's just put it a fraction. 8 hours. And then we have to break it down in terms of cars. So when we break it down, let's just multiply with the conversion factor. What was the conversion? 7 cars to 3 hours. Now, since we have 8 hours on the top, in order to cancel the hours unit, we have to put the hours in the bottom and cars in the top. So it will be 7 cars on top and 3 hours at the bottom. So the hours and these hours gets cancelled. So over here we get 8 times 7 is 56 over 3 cars. I hope this was easy for you to understand. Let's do another example and clear the confusion if we had any. Here, we have been told that one box can hold 24 muffins and 7 cups of flour are required to make 9 muffins. How many cups are required to make enough muffins for 15 boxes? Now, this is what we call a multi-step unitary method problem. So there are actually 2 conversions. What are those conversions? The first conversion is 1 box equals 24 muffins. The second conversion is 7 cups equals 9 muffins. So we get the conversions right from here. And for the first one, 1 box equals 24 muffins. We can get it right from here. So now we have written down our conversions. What do we need? We need how many muffins or how many cups are required to make 15 boxes. So we will need 15 boxes. And how many cups? So first we have to convert boxes to muffins, and from muffins to cups. So first things first, let's just write down what we need. We need 15 boxes. And then we are converting them to muffins. So what is the conversion of muffin to boxes? 1 box equals 24 muffins. So if we want to cancel out boxes, we have to put box at the denominator and muffins on top. So it will be 24 muffins divided by 1 box. And from here, the box unit can be cancelled out. And from the muffins, we can get into cups. What is the conversion of cups and muffins? 7 cups equal 9 muffins. And since we have muffins on top, we have to cancel the muffins. So we're going to put muffins at the bottom. So it will be 7 cups, 9 muffins. And then we can cancel out the muffins from here. I guess we have found our conversion. So what it comes down to? 15 times 24 times 7 over 9. That's the number of cups that we require. The answer comes to 280 cups of flour. So now it's clear. If we want to use this conversion method rule, the unitary method rule, then first what we have to do is we have to find out what is required in the question. It was required how many cups of flour would be required to fill in 15 boxes. So we wrote 15 boxes first. And then we are going to convert the 15 box into muffins. And what was the conversion of box to muffins? We had 1 box equals 24 muffins. So we put 24 muffins on top and 1 box at the bottom because we want to cancel out the box unit. And then we have to convert this entire muffins into cups. So what was the conversion of cups to muffins? 7 cups equal 9 muffins. So we are going to put muffins at the bottom so that we can cancel out the muffins unit, and we have 7 cups at the top. So this will be left with only cups. Now we have 15 times 24 times 7 over 9 cups. The answer is 280 cups of flour is required to fill in 15 boxes of muffins. We are going to do one last example and see how well we can do the algebraic word problems. In our final example, we have for every 500 calculators produced by company X, 3 have defects. If company X produced 40,000 calculators in a month, how many defective calculators will they produce in a year? So they are asking for how many calculators they will produce in a year. So what are the conversion rates? We have 500 calculators and 3 defects. Now we have another factor as well, in a month. So let's write down the conversion factors and let's get it over with. Our first things first, 500 calculators has got 3 defects. The next thing that we have to know is that they produce 40,000 calculators in a month. So 40,000 calculators in 1 month. And finally, we have how many calculators will they produce in 1 year, or how many defective calculators will they produce in 1 year. So we have 1 year equals 12 months. How are we going to solve this problem? We have year to months, month to calculators, calculators to defects. So I guess it's pretty much clear. Year to months, months to calculators, and calculators to defects. Let's do this problem and see if we can solve this out. First, we are going to use what we are given, the number of years, how many calculators we are going to produce in 1 year. Let's solve out this problem and see how we can do it. Our first things first, we have to calculate how many months are there in 1 year. So we are going to do 1 year by 1, and we're going to convert them into months. So we have 1 year equals 12 months. We're going to put 12 months on the top and 1 year at the bottom. Why did I put year at the bottom? Because I want to cancel out the year units. So the year units are cancelled out. Now we have months. Next, we have to convert the months into calculators. What is the conversion factor? 40,000 calculators equals 1 month. So we are going to put 40,000 calculators divided by 1 month. Why did I put month at the bottom? Because I want to cancel out the month units. And now we have calculators. I want to know the number of defects. So what is the conversion factor? 500 calculators, 3 defects. So we are going to write 3 defects by 500 calculators. Why did I write calculators at the bottom? Because I want to cancel out the calculator units. Now let's see what we have. We have 12 times 40,000 times 3 over 500 defects. We have 2880 defects in 1 year. So that is the answer to our question. I hope these examples were helpful for you to solve all kinds of word problems in our algebra or in SAT exams. Thank you for watching this video. I'll see you in the next one.